Today, we're going to talk about back titrations, which is an analytical technique where you take a certain amount of a particular reactant, and you know how much there is, and you know that it's going to be excess. So then you would, drop in the reactant you're trying to analyze or determine, knowing that you've got too much stuff in there. Then you will, after that reaction is complete, determine the amount of excess stuff that you added that is left over, and from that you will work backwards to find out the original amount of the reactant you're trying to find. In this case, we're going to look at an example of analyzing an antacid by reacting it with excess acid, and then determine the amount of excess acid that's left over to sort of back calculate how much antacid was in our original sample. So if we look at the first thing we have, right, we're going to start with 3.5 gram sample of some antacid tablet that contains calcium carbonate. We're going to add an excess of acid to that, and then after that reaction is complete, we'll determine the amount of extra acid that's left over, and from that we'll calculate. So the first thing we're going to want to do is write a balanced equation for the reaction between the HCl and the calcium carbonate, which are an acid, as well as realizing we're trying to find the percent of calcium carbonate in our original sample. So that'll make sure we have grams of calcium carbonate over grams of our tablet. So at some point we'll have to come back to that so that we can figure that out. So the first thing we want to look at is, of course, the reaction between HCl and calcium carbonate should require 2 HCl's, 1 calcium carbonate. So we get calcium chloride, which would be our salt, as well as then H2CO3, which is carbonic acid, right, or hydrogen carbonate, and that automatically becomes water and CO2 gas, right? Which is why when you take an antacid, if you have stomach acid or an upset stomach, it causes you to belch and burp that carbon dioxide. It helps relieve. It's just the excess acid being used away. So we have 2 HCl's for 1 calcium carbonate is our big important thing we need to realize there. All right, so the first thing we want to do is look at then if we're going to react 100 milliliters of 0.5 molar HCl with this tablet that has a mass of 3.25 grams. And I can go ahead and put that 3.25 gram tablet into my formula for determining the mass percent, so I already know that's my sample size. Well, I've started with 100 milliliters of 0.5 molar HCl, so the first thing I want to do is figure out how much HCl is that. So, original HCl would be 0.5 molar times 100 milliliters, which would give me 50 millimoles, or 0.050 moles. I prefer to use millimoles. I'm going to do my calculations because milliliters, millimoles, it sort of makes sense. But that's the original acid. The second thing says then we react it with the 3.25 gram tablet. It reacts, and there's some left over. So after we figure out how much we started with, we need to figure out how much of that acid is still left after that calculation, after that reaction. To do that, we know that we're going to treat it with NaOH, and we should realize that's a strong 1-to-1 ratio, so that the molarity times volume for the NaOH must equal the moles of NaOH. That must be equal to moles of HCl. So to do that, I have the molarity was 0.1, the volume 45.40 milliliters, which means I have 45.40 millimoles of HCl that was reacted. Now, that HCl was reacted, has been consumed and used up by the reaction with my antacid tablet and the calcium carbonate. So once I know there's 45.4 milliliters of HCl that's gone, I can figure out by just subtraction how much is actually left over. And this should actually not be 45.4, it should be 4.54. If I could do a little bit of math, we'd see that. So if I look at 50 minus 4.54, that tells me that I had an amount of HCl that reacted that was 45.46 millimoles. 45.46 millimoles that reacted with the calcium carbonate. So now, I know how much HCl there was, and I should be able to determine then from the HCl how much calcium carbonate was in my original sample. So if I look at changing that, now I just have to say, well, how many moles of calcium carbonate were in my tablet, and then how many grams of calcium carbonate that's equal to, because I need grams of calcium carbonate in order to determine that original mass percent. So I've got X moles of calcium carbonate are equal to 45.46 millimoles of HCl. And those millimoles of HCl, like I said, were the amount of the original 50 millimoles that reacted when I added my tablet. Well, if I look at HCl to CaCO3, there's 2 HCl's for 1 calcium carbonate. That means I have 22.73 millimoles of calcium carbonate in my original tablet sample. Determining that, changing that into grams, X grams of calcium carbonate equal to 22.73 millimoles of calcium carbonate. The molar mass of that calcium carbonate is 100.09 milligrams per millimole. And I end up with 2.275 grams of calcium carbonate, or 2,275 milligrams. So if I substitute that 2.25 grams, 2.275 grams calcium carbonate over my original 3.25 gram sample, then I end up with 70% calcium carbonate as my original analysis or assay, if you want to say it that way, of my tablet. Right? So 70% of the tablet was calcium carbonate, and the other 30% was just other stuff that was added in there to make the tablets a certain size, or perhaps add some other elements or whatever to give it some certain qualities. So that's an example of a back titration. Once again, you're going to take a known amount and that's in excess. You're going to analyze to find out how much is left over. And then by subtraction, find out how much actually reacted. And once you know how much actually reacted, you can determine grams, molarity, or whatever it is about your original sample. In this case, the percent by mass of active ingredient, calcium carbonate, in my sample. So start with an excess that's known to be excess. Determine the leftover, usually by titrating, and then allow, by subtraction, to find out how much actually reacted with your excess, and then calculating using your stoichiometry. So you got that problem there. There's a couple other problems on that Moto page as well to deal with back titrations. We'll look at this on Thursday in class, so make sure you watch this by then and work through that sample problem that's there. And so we'll be good to go and prep for our quiz on Friday.